Okay, let's try the hyperbola function question here. Starts off and it says, state the equations of the asymptotes of f. The asymptotes are these lines you use to graph. There's a horizontal one, and it's y equals -1. And there's a vertical one, the place where the hyperbola can never touch. It's when the bottom of this fraction is 0. So it's x equals -2. Those are the two equations, the horizontal and the vertical asymptotes. Then it says, find the x and y intercepts. Find the x and y intercepts. Well, the y-intercept is easiest. You just put a 0 in there, and 4 over 2 minus 1. The y-intercept is 1. So that's 0 and 1. The x-intercept's a little bit harder. You let y equal 0. Takes a bit of thinking. You might see the answer here, but I think people like to add 1 here. That's one way. You could multiply everything by x plus 2 and so on, but this is good. Add 1, then multiply by x plus 2, then subtract the 2, and x equals 2. Oh yeah, 4 over 2 plus 2, 1 minus 1, 0. That makes it work. So x equals 2. The x-intercept is 2 and 0. And if you put 0 in, 4 over 2, like I said, you get y is 1. So there's the y-intercept, there's the x-intercept, there's the asymptotes. So what you do to sketch the graph, I think that's what 5.3 is. They ask you to sketch the graph. All you do is go to x equals -2 and put a vertical line. Go to x equals -1. There's the origin right there, 0 and 0, the x-axis and y-axis. And put -1. Then on where x is 2, it hits right there. Put a 2. Where y is 1, that's the y-intercept. Put a 1 there. You've got a curve, a hyperbolic curve going through there. And that's your answer. And then you just put another branch down here. Ooh, I didn't mean to put that down there yet. And you just draw the other branch in. But you don't need any points, and it doesn't have to be perfect. This is a computer doing it perfectly, just the general shape. Now they say there's this axis of symmetry. There's 2 of them that go right through this point here where the asymptotes cross. There's one that's got at -45 degrees and one at +5. They want the one where the gradient's -1. That's this one. And they want that point, -2 and 1. It's right where they cross. It's right where they cross. I meant for that arrow to go right there, right where they cross. And we're going to be able to find what k is there. Because all we have to do is take the y value and put it in for where y is. Take the x value of -2 and put it in, and we're going to get k. Let's see here. This is +2, and then we subtract from -2. K is -3. Hey, that looks about right, too, even. It should be down here where it's crossing the line. That's the graph. It's got a gradient of -1, and down here is -3. Okay, let's see what the next question is. It says, h of x is a reflection of f in the x-axis. Determine the equation in the form y equals. A reflection in the x-axis, you just have to know. If you're up here at 2 and -3, there's a little point. And if this is the mirror, you'd see yourself down here at 2 and -3. That's a reflection in the x-axis. It works for all the points. All you do is take the y-coordinate and make it negative. So it's the easiest thing in the world. Take the y-coordinate, make it negative. So take this y and make it negative. That's 1 mark. That's the answer, except it's supposed to be in the form y equals. So we multiply both sides by -1, that by -1. -1 times -1 is +1. There it is in the form y equals -4 over x plus 2 plus 1. That would be a reflection in the x-axis. I don't have to graph it or think about it. If they say reflection in the y-axis, then the x becomes minus. Hey, that's a good thing to remember. We don't practice much of that. We did it in grade 9, but it's something they can ask now.